Okay, here's the next step in this project. You'll notice I've taken one of the pairs that we're working on, C2 and C6, forms a system of equations, and that system is made up of x plus 2y equals 8 and x equals 1/2 minus 2y. And what we're going to do with this document, and there's one of these tables for every possible pair, is we are going to support what we have on our poster using the algebraic methods of substitution and elimination to define the nature of the system. So I'm going to run through this example. In the first set of equations, we're being asked to use substitution to show the nature of this system. Now, you need to make a decision when you're working with substitution. I'm going to substitute x or y from one equation into the other. So there may be some rearranging that you need to do, but in this case, we really can take advantage of the fact that I already have x is equal to something. So I can substitute that right into the first equation. So I can substitute what x is equal to in the second equation into the first equation. And that's how I am combining those two equations algebraically. So now you'll notice I'll take this and I'll put it in what x is equal to. I have 1/2 minus 2y in for x. I'm going to rewrite this equation, plus 2y equals 8. Now I'm going to solve for the variable y. And what you're going to find out is that when I combine like terms, I have negative 2y and positive 2y, I end up with 1/2 equals 8. And from our previous work, we see when we end up with a solution to the system of equations that is not a true equality, this is a false statement, we know that there are no solutions. So we know that if we graph these, if all this work is done correctly, when we graph these, I should have a set of parallel lines. So now on your poster, you should have these two graphs with an arrow indicating from one to the other that there are no solutions because these form parallel lines. We're going to check our work also by doing the process of elimination. To work with elimination, we have to get our x's and y's all to line up. This is nice, neat standard form. I'm going to put this equation in standard form by adding 2y to both sides. And now you'll see I have an equation that is in standard form. Now, when I go to combine these two equations, and when I go to add them, nothing's going to cancel out. So I'm going to multiply this equation by -1. And what you'll see is when I multiply everything in the equation by -1, I end up with this equation. Now I'm going to combine these two equations. X plus 2y equals 8. I'm going to add to it negative x minus 2y equals -1/2. And you'll notice x plus a negative x is 0. 2y plus a negative 2y is 0. I end up with 0 equals 8 plus -1/2 is a 7 and 1/2. Again, I end up with a statement that isn't true, just as I did with substitution, both of these indicating that this system has no solutions. So what you'll do with this sheet is you'll go through every possible pair. There will be 14 other possible pairs, and you will show using the method of substitution and elimination that the conclusion you came to on your poster board is correct. Now, if you're looking at this and you haven't been in class, what I've done is I've gone ahead and I've listed the equations here. So you can at least get this work done. What you might want to do now is you might want to pause the video and make sure that you have all these equations so you can go ahead and begin the process of putting this document together. I will go ahead and share out this document with everybody so that they have it available.